Hello, welcome back. So now we're going on to dependent and independent events. So we're going to start off with the independent events. So here, the occurrence of one event does not affect the probability of the occurrence of the other event. So let's take an example or two. Let's say we flip a coin. So what we flipped before is not going to affect what we flip now. And what about rolling a dice? Let's say we roll a dice. So whatever we rolled before is not going to influence what we roll now. So those are independent events. But now, if the events are not independent, then they are dependent. So let's take an example of dependent events. And this is what we did in the previous class. So remember, E, that was the probability that the economy is in expansion, and S, that was the probability that the sales of Riverside retail increase. Now, these two guys, they're not independent, because if the economy is in expansion, then of course it's going to affect the sales of Riverside retail. So remember, the PS, that was the unconditional probability. That was the probability the sales increase regardless of the state of the economy. But the probability that sales increase given that the economy is in expansion, that was 75%. So what we can conclude is that the probability that sales increase is greater when the economy is in expansion. Right, so let's go on now to the independent events. So if A and B are independent and we want to work out, what's the probability of A and B, all we need to do is multiply their probabilities together. So remember the multiplication rule that we did in the previous class, that was for now dependent events. It looked like this. Let's just go back to refresh our memories. There we go. There was a multiplication rule for the dependent events. So we took the probability of A and B, was the probability of A given B, multiplied by the probability of B. So now, when we've got independent events, it just makes life a bit easier, because all we need to do to work out the joint probability, the probability of A and B, all we need to do is multiply the probabilities together. So now if we've got A, B, and C, and they are independent events, again, all we have to do is multiply the probabilities together. So let's try some examples here. So first of all, what is the probability of rolling 2 6s in a row with a dice? So this is now independent events, because what was rolled before is not going to influence what is rolled now. So all we need to do is take over here, what's the probability of getting a 6 with a first roll? Well, it's 1/6. And what's the probability of getting a roll with getting a 6 with a second roll? Also 1/6. So it comes out at 0.278. So that in percent is what? That's 2.78%. So there's only a 2.78% chance of getting 2 6s in a row. Now, what's the chance of getting 3 6s in a row? Well, that's tiny. Then I've got to do 1/6 times 1/6 times 1/6. So that's 0.0046. So in percentage, that'll be what? That'll be, move the decimal 2 places there, so it'll be 0.46%. Wow, that's not very good at all. Kiddos. So let us continue. So now we're going on to the unconditional probability using the total probability rule. And this is the total probability rule over here. So the probability of A is the probability of A and the probability of S1. So remember that if there's nothing in between the two letters, we say we say and in our head. And now we've got to add on here the probability of A and the probability of S2, etc., etc. So now, if you haven't read ahead, this might look a bit hectic, but it's not. So we don't have to freak out. It's not as bad as it looks. What are we doing here? We're just applying the multiplication rule, because what is this? This is the probability of A and S1 happening, which is what? Which is the probability of A given S1 multiplied by the probability of S1. And we do the same then for each and every term, where all of these are mutually exclusive and exhaustive events. So let's try the example and we'll see, it'll help to understand what's going on here. So first of all, to give us all this information here. So the probability the economy is in expansion, we're going to call that PE, that is 60%. That must mean that the probability the economy is not in expansion, that must be 40%. So now the notation we can use is PE to the C. That means we are now, this is the probability we are not in expansion, E to the C. So all we're going to do is take 1 minus that, that's 40%. So this PE to the C, it means it's not E, it's not that one. And it's also, and the C is because it's also called the complement. So that's why they've got the C over there, because it also can mean that is the complement of E. Right, now these two, they are of course mutually exclusive because they can't happen at the same time. So we can only get one or the other. So either we're in expansion or we're not in expansion. Right, so now now they give us more info here. They tell us the probability the sales increase given the economy is in expansion, that is 75%. And the probability the sales increase given that the economy is not in expansion, that is 55%. So that makes perfect sense because we would expect, the sales to be, there's a much higher probability of sales increasing when the economy is in expansion, as compared to when it is not in expansion. So now they want us to do this whole thing here. What is our unconditional probability that the sales increase? So this unconditional probability over here, it is, if we look at the top of the slide, the sum of the joint or the conditional probabilities. We're taking the sum here of these joint or the conditional probabilities. Right, so let us now put it all together. So we've got to break up these joint probabilities here using our multiplication rule. So we need to take, so the probability of the sales increase is equal to the probability of the sales increase and the economy is in expansion. And then we've got to add on the probability here, the sales increase and the economy is not in expansion. So here comes our multiplication rule. So with this one, we've got to break it down. So the probability sales increase and the economy is in expansion is equal to the probability sales increase given that the economy is in expansion. We're going to multiply that by the probability the economy is in expansion. And then we're going to do the same on this side. We're going to break it down. So it's going to be the probability the sales increase given that the economy is not in expansion. We're going to multiply that by the probability that the economy is not in expansion. Right, so that is all the hard work done, and that's our total probability rule there. So now we can just plug in the numbers from the slide before, and we'll see that it comes out at 67%. And we can also draw a probability tree. Now we are going to do the probability tree in a few minutes time, so it might be easier after we've done that, but let's just have a quick look here anyway, and then maybe you can come back to the slide after we've done the tree. So we do it like this. So the probability the economy is in expansion is 60%, like we've been given, which means the probability we're not in expansion, that's going to be 40%. So now they told us the probability sales increase given we're in expansion. So given we're over here in the top half of the tree, that let me say it again, the probability the sales increase given we're in expansion over here, that was 75%, which means that the probability that there's going to be no increase in sales given that we're in expansion, that's going to be 25%. But we don't actually need this information at all, because all they're asking us for is what is the probability of sales increasing. We're not worried about sales not increasing, so we don't really need that, but I just put it in there just so we can understand, what this other little bit of info is. And now we need to do the bottom part of the tree. So we now need to now they've given us here on the previous slide, they told us that the probability that the sales increase given that the economy is not in expansion over here, so we're not in expansion over there, that was 55%. And again, we don't need this information here, but if we wanted to know it, we could work it out, that the probability here that we have no increase in sales given that the economy is in expansion, that'll be 1 minus 0.55, which will be 0.45. Okay, but again, we don't need that. So now to work, and now all we need to do is multiply across the branches. So we're going to take 0.6 times 0.75 is 45%, and 0.4 times 0.55, that is 22%. We add the two together and we get there the same, the 67%. And now we can see, what's the probability that sales increase, because we're only looking at here, probability sales increase there, probability sales increase over there. Good. So that takes care of that. So now we're going on to the expected value of a random variable, and this is something nice and easy. It's the expected value of a random variable. All it is the probability weighted average. So now we're coming back to our weighted average formula again, of the possible outcomes of the random variable, and we denote this EX. So the expected value, then we take the sum of, so the PX over here, this is going to be the probability of the outcome occurring, and we multiply that by the return under that outcome. So then we've got to do it for each and every outcome or scenario. So let's call this scenario 1 over here. So this is going to be the probability of scenario 1, and all we do is multiply that by the return under scenario 1. And this is going to be the probability of scenario 2, and we multiply that by the return under scenario 2. And we're going to do that for each and every scenario. And we are going to do an example on the next slide, and we're going to see it's not bad at all. So the example we're going to do for the previous slide is actually this one over here. But just before we get to that, we got to look at a few other things, because we're actually going to be killing 2 birds with 1 stone here. So we're now going to go to variance and the standard deviation of a random variable. So we have visited variance and standard deviation before, but now we're doing it in a slightly different manner, because now we're using the probability model. So remember variance, the symbol for variance is there, that's sigma. So it's variance, remember, is sigma squared. So sigma squared means the variance. So the variance of X now is equal to what? It is the sum of, and just before we carry on, this sign sum of is also sigma, but I think I may have mentioned this before in a previous class, but I just can't quite remember. This one I think is lowercase sigma in Greek alphabet, and this one is uppercase sigma. So at least we're learning the Greek alphabet, yeah? Right, we just need to have a bit of fun here and there. Okay, so let's continue. So what do? We take the sum of here. So PX, that's going to be the probability of the outcome, and we multiply that by the return under that outcome, and we got to subtract from the return under that outcome the expected value. That was the expected value formula that we looked at on the previous slide. We actually got to then square that deviation over there. So remember, from what we discussed before under variance, or rather what we discussed before with variance might be the better way to say it. Variance, remember, is the squared deviation here, the squared deviation from the mean. So the expected value, we can also view it like as the mean. So it's the squared deviation from the mean. So now we're going to call it the squared deviation from the expected value. And you might remember what we did before with variance. We took all of those squared deviations and we divided by the number of observations minus 1. But what we're doing now with the squared deviations, we're multiplying them rather by the probability of the outcome occurring. So that's the only difference. So now it's the expected. So what we've got here is the expected value, or the probability weighted average of the squared deviations there from the random variable's expected value there. There's expected value. We look at the squared deviations from the random variables expected value. So let's go straight to the example, and we're going to see it's not so bad. So here we've got 3 scenarios. So the probability of scenario 1 happening is 20%. And if scenario 1 happens, then the return on stock A is going to be 15%. And the probability of scenario 2 happening is 50%. And if scenario 2 happens, then the return on stock A is going to be 12%. And the probability of scenario 3 happening is 30%. And if that happens, the return on stock A is going to be 7%. So scenario 1 looks like good economy, because that's when stock A is the best. Scenario 2 looks like maybe normal economy, and scenario 3 looks like poor economy, because that's when the return is the worst. So here is our expected return on stock A, and that is our formula here from the previous slide. Nice and easy. All we do is we take the probability of scenario 1 happening there, which is 20%, and multiply that by the return under scenario 1, and we do that for each and every scenario, sum them all up, and that's going to be our expected value, 11.1%, or we can also view it like almost like a mean. Hey, so now to work out the variance there, the variance of stock A, all we got to do is take the probability of scenario 1 happening and now multiply that by the return under scenario 1 less the expected return, or the expected value, whatever you want to call it, and with that difference there, it must be squared, right? And then we need to do that for each and every scenario. So scenario 2's got a 50% chance of happening, and the expected return under scenario 2 is 12%. And again, we subtract that, we subtract the expected return from that, and we square that difference there. And the same then for scenario 3, it's got a 30% chance of happening. And if scenario 3 happens, we're going to get a 7% return. And again, we subtract the expected return there, and then we square that difference again, right? And we sum everything up, and there's our variance. Now, I've just put in some notes here, because very often on the exam, they like to ask the more conceptual things. And I think we have discussed this before, but it's good revision. So remember, the higher the variance is, the higher the dispersion or the risk. And also remember this one, that variance is measured in squared units of the original variable. So it's not really that useful. What is better for us? Standard deviation. We're coming to that in 1 minute. So, and I also picked this little block that I put in here. I picked this up from one of the CFA Institute practice problem, where they said, what happens if variance is 0? Well, if there's variance is 0, then there's no dispersion or risk. This means the outcome is certain, and which means the quantity then is not random. We're talking about random, but if it's 0, then it is not random. So now, to work out the standard deviation, we know exactly what standard deviation is. It's just sigma, and then it is the square root of the variance. So now it comes out there 2.91%. And that is why we like standard deviation so much, because it is in the same units as the variance, as the variable. So it's in percentage as well. So it is much more useful, the standard deviation, compared to variance. And we have also discussed that before. So let us move along. Right, so now here comes the probability tree and its application to investment problems. So this is something that's quite a bit of fun. So let's have a look what we've got here. So we've got the dividends per share that Riverside Retail pays depends on the economic scenario that prevails. So scenario 1, it's got a 60% chance of occurring, and scenario 2 has got a 40% chance of occurring. So now they give us the dividend per share under different scenarios. So if scenario 1 has got a 60% chance of happening, like we said there, and if scenario 1 occurs, then there's going to be a 70% chance that the dividend per share is $3.90, and there's going to be a 30% chance that the dividend per share is going to be $3.70. And now scenario 2, like we said, it's got a 40% chance of happening there. And if scenario 2 happens, then there's going to be a 60% chance that the dividend is going to be $3.30. And there's going to be a 40% chance that the dividend is going to be $3. So it looks like scenario 1 is good economy, because there we're getting good dividends, and scenario 2 might be poor economy, because here the dividends are not as good as up there. So we got 3 questions to answer. Number 1, what is the expected dividend per share? And number 2, what is the expected dividend per share given the first scenario, this scenario over here? So this is like a conditional probability there. And this one is also a conditional probability. What is the expected dividend per share given the second scenario over there? So let's then draw our tree. And they told us the probability of scenario 1 is 60%. And then they told us that if scenario 1 happens, then there's going to be a 70% chance of getting $3.90 dividend. So now to work out the probability of getting this $3.90 dividend, all we've got to do is multiply across the branches. So 0.6 times 0.7 is going to be 0.42 or 42%. And then they also told us then here that if scenario 1 happens, then there's going to be a 30% chance of getting $3.70. So what's the probability then of getting $3.70? We just multiply across the branches. 0.6 times 0.3 is 0.18 or 18%. And then now turning our attention to scenario 2, they said there's going to be a 40% chance of that happening. And if scenario 2 happens, then there's going to be a 60% chance of getting $3.30 dividend. So now the probability thereof is going to be 0.4 times 0.6, which is going to be 24%. And then lastly, if scenario 2 happens, then there's going to be a 40% chance of getting a $3 dividend. And then to work out that probability, it's just going to be 0.4 times 0.4, which is 16%. So now if we add up all of these here, 42 plus 18 plus 24 plus 16, that must equal 100%. Okay, oopsie, sorry about that. Now I did check this before we started, so it is correct, but you can just double check. And now we've done all the hard work. So now to work out the expected dividend per share, all we need to do is what? A weighted average calculation. Nice and easy. There's a 42% chance there of getting $3.90. There's an 18% chance of getting $3.70. There's a 24% chance of getting $3.30. And there's a 16% chance of getting $3. So our expected dividend per share there's going to be $3.58 over there. Good stuff. Now we need to answer those other 2 questions that were at the bottom of the previous slide. The first question, this question here, what is expected dividend per share given the first scenario? So they're asking us the expected dividend per share given scenario 1. So now this actually makes life easier because they're telling us given scenario 1. So all we need to do is focus on the top half of the tree. So if we're given scenario 1, well, then there's going to be a 70% chance of getting $3.90 there. And there's going to be a 30% chance of getting $3.70 there. That's it. Because we only focus on the top half of the tree because it says given scenario 1. So let's try the next one. What's the expected dividend per share given scenario 2? So now all we need to focus on is the bottom half of the tree, scenario 2. So if we're given scenario 2, then there's going to be a 60% chance of getting $3.30 there. And there's going to be a 40% chance of getting $3 over there. So that's going to be $3.18. Good. So that takes care of that. And now we are, I think, yes, this is the last slide for this class. And the good news is this is a nice, easy slide to end off with. It's just the expected value now of portfolio returns. So the expected value on a portfolio, all we're going to do again is our friend, the weighted average of the expected returns on the component securities, and we're going to use the respective weights. Of course, we're going to use their respective weights in our weighted average formula. So there's the weight there, the weight that we've got in, call it asset 1 or whatever we want to call it. We multiply that by the expected return on asset 1. Then we're going to take the weight we've got in asset 2 and multiply that by the expected return of asset 2, etc. So nice and easy. So here is our portfolio. So our portfolio, we've got 40% in equity, we've got 35% in bonds, and we've got 25% in cash. So to work out the expected return, all we're going to do is take, we've got 40% there, and we multiply that by the expected return in equity, and we've got 35% in bonds. We multiply that by the expected return of the bonds there, and we've got 25% in cash. So we multiply that by the expected return of cash, and we just sum it all up, and there's the expected return, 8%. So that's it. And I told you it was a nice, easy slide to end off with. So I hope that was helpful. The class was helpful, and then we'll see you guys in the next class. Hello, it's Tim here again. I hope you enjoyed the class and found it beneficial. We have some classes available for free on YouTube, but we have classes for the entire curriculum. The classes that are not on YouTube can be purchased from us. If you'd like to purchase the classes, please contact us for the pricing, and I've put our contact details over here. You can purchase all the classes or certain readings that you would like. When you purchase the classes, we provide you with the slides and our notes. I've assisted hundreds of candidates pass CFA exams, and I look forward to also helping you through the CFA program. I've put in 2 testimonials in the slide over here, and we also have a testimonials page on our website that you can review. I look forward to seeing you soon, and all the best.